we want to tell you about a program called Cubes in Space. This program allows high school and middle school students to propose and build a project that will either go on a sounding rocket or a weather balloon if approved by NASA.
Cubes in Space is the ultimate opportunity for kids to learn and make awesome connections with other like-minded kids.
I would recommend the Cubes in Space program for everyone.
So, picture a Faraday flashlight, like one of these. A Faraday flashlight works by shaking a magnet through a copper coil, and then you can turn it on and generate light. So our project is basically a Faraday flashlight, but instead of a light, it's a recording device. The purpose of this experiment is to test whether or not usable electricity can be generated using vibrational forces on a rocket launch. We are planning to generate electricity using Faraday's law, or otherwise known as electromagnetic induction, to generate power.
This is our Faraday charger. It works by using the magnetic field of this neodymium magnet to induce an electric charge in this coil.
We did tons of iteration on the coil design. We needed to wind each one and test each one independently. We ended up recording this all in a spreadsheet and choosing the best one out of all of them. The magnets and supercapacitors were tested in the same way as the coils.
When we were doing the experiments, it was pretty cool because we would, even though we didn't have a rocket to test, we would use something else like a saw moving back and forth.
This project required several components to be custom designed and 3D printed. A huge amount of iteration needed to be made to get the design just right.
This project took so much 3D printing. We have about like a box full of failed prints. So it was a bit harder, but in the end, I feel like the results were worth it to see everything come together.
This project really pushed our engineering and 3D design skills.
This recording device consists of a microcontroller. Eventually, we settled on 80 tiny 85Vs. After we finished our breadboard circuit design, we moved on to a printed circuit board. A printed circuit board is basically a permanent version of a circuit. Now, to make the PCB itself, we used a PCB design software called KiCad. After the PCBs arrived, we needed to solder the components in. Soldering is a way to easily connect components on a PCB into their pins. Some of the components were through-hole components, which means that the leads went right through it. The hard ones were SMD, or surface mount devices. I learned a lot from this project, coding different MCUs in different programming languages, making PCB designs that will work. I learned a lot about coils, magnets, and supercapacitors, how to work on a team,
How to write formal emails.
lastly, how to write proposals for agencies like NASA.
When we were writing the proposal, we would have to say what our project was about and what were the dependent and independent variables.
We learned a lot about electricity and the process of doing scientific research.
The coding of this project required tons of iterations. We had at least 10 different versions, and they each had different features and bug fixes. On our way to Wallops Flight Facility in Virginia, where the rocket was going to be launched from, the tension was super high and we were all waiting nervously to see if our experiment had worked.
The launch was really cool. Like, the rocket launched and the sonic boom came later. You could hear the sound taking time to travel to you, and it went really fast, and it was really cool to see the rocket stages cut off and then start up again.
It was also really exciting to see the rocket come back up close on the recovery road. Now, once we got home, we started looking at the data. Apparently, there was no data written on the cube. This means that the vibrational force of the rocket was not high enough in order to shake the magnet in our cube. We would like to share our results with the scientific community to make sure that they know that this method of generating electricity will not work on a rocket.
I would definitely do Cubes in Space again and again and again because it's really fun, and I really enjoy coming to every single class and working on it.
I would love to do Cubes in Space again.
We absolutely enjoyed the whole process.
I'm pretty happy of what we've accomplished. It's kind of just nice to just work with other people, especially since COVID.
Plus, I made a lot of good friends along the way.
I made friends on the project. I made 3.
It was really fun.
Cubes in space are great for kids like me.
We'd like to thank Bob Finney, Derek Rowell, Amber and the rest of the Cubes in Space team, and all of our parents. Bye!
That's it.